This is question 4, a 9-mark question from paper 2 of the AS 2017 biology paper. It starts with scientists investigated how the concentration of protein in blood plasma changes in people between the ages of 60 and 95. Figure 4 shows the scientists' results. The bars show plus or minus 1 standard deviation. Okay, so even before we move on, we can just take a little look at that. We can see that the males is the dotted line, the female the solid line, and we can see that they both decrease, the female decreasing more than the male. And we can also see that the standard deviations overlap apart from the results at 95 years, which don't overlap. Okay, so now we've taken a little bit of time to get to know our graph. Let's see what the first question asks. What is the difference between males and females in the fall in mean concentration of protein in blood plasma between 60 and 95 years? So, in other words, how much does the males fall by? How much does the females fall by? And because it's asking for the difference, we're going to subtract one from the other. So the females dropped by 11 and the males dropped by 5, and that left a difference of 6. According to the examiner's report, one of the things that they said was that students lost mark on this question because they didn't read the key properly in terms of which line represented the male and which line represented the female. So make sure you don't make that mistake. Okay, the next question says use figure 4 to calculate the rate of change of the mean concentration of protein in the blood plasma of males between the ages of 60 and 95. So no tricks there. We're going from one end of the graph to the other. And they've given us nice whole numbers to work with using the scale on that graph. So the fact that it's asked for the rate, whenever we see the word rate, we know that we mean over time. And this is where most students lost their mark because they didn't do the calculation, basically. They didn't divide it by 35 years. So we know that for a male, he had a decrease of 5. So all we need to do is divide that by 35 and we get 0.14. And we can't leave that as a fraction, i.e. 5 over 35, because then we're asking the examiner to do some work. And they've given us the units that they want us to present that in, which is grams per decimetre cubed per year. On to the next question. What can you conclude from figure 4 about the effect of ageing on the mean concentration of protein in the blood plasma in males and females? Well, we can see that there's only 2 marks for this. So the general trend is that it decreases, and it decreases more in females than it does in males. Now that was worth just 1 mark. As they have gone to the trouble of calculating and plotting the standard deviation on our graph, we need to say something about it. So because we're looking for information about the effect of aging on mean concentration of protein. So we're going to say that the difference may only be significant at 95 years, and that's because at that point the standard deviations do not overlap. So rule of thumb, if there are standard deviations shown on there, you need to comment about where they overlap and where they don't overlap. Remembering that where they overlap, we say there is no difference, and where they don't overlap, we're saying that there may be some significance between the results, but we don't know until we do further statistical tests. Moving on to the next bit, the scientists measured the absorption of each sample of blood plasma using a colorimeter. They used a calibration curve to find the concentration of protein in samples of blood plasma. Describe how the scientists could obtain data to produce a calibration curve and how they would use the calibration curve to find the concentration of protein in a sample of blood plasma. So this is testing your CPAC skills that were seen in Practical 3, where you made a serial dilution and you used a colorimeter to plot a calibration curve. There are only 3 marks for this question, so they don't want too much detail. Basically, what we need to say is that we would use known concentrations of protein. We would measure their absorbance of each concentration with a colorimeter. Then we would plot the absorbance on the y-axis and the concentration on the x-axis and draw a curve. And then we would use absorbance to find the concentration from the curve of a sample we were trying to identify the concentration of protein within. Now, according to the examiner's report, they marked it wrong when students wrote about making various concentrations of blood plasma. However, I know what the students were trying to say, because within the blood plasma, if you just measured it against concentrations of protein, obviously in blood plasma there are other constituents, other things that are going to affect the absorbance. And so the answer that the mark scheme has published doesn't take that into consideration. So I can totally see why students would talk about making a serial dilution of the blood plasma with known concentrations of protein in it, but the mark scheme has glossed over that. The final part of the question says old people are more likely to suffer from infectious disease. Suggest how this may be linked to the decrease in the mean concentration of protein in the blood as people get older. Well, it's the idea that antibodies are made from protein, and so if you've got lower levels of protein in your blood, perhaps you won't be able to make as many antibodies, and therefore you would be more prone to infectious diseases. Thank you for watching. I hope it has been useful. Please do remember to leave me a comment.